Everyone, in this video, we're going to focus mainly on 6 MCQs using Euler's method that most tested on the AP Calculus BC exam. Alright, so we're going to use point slope form of equation of tangent line y equals m times s minus s1 plus y1, right? Where m equals dy over ds and s minus s1 is the step sign. Sometimes we're going to name step sign as h or delta s. y1 is the value of y the first time. Now let's move on to question 1. Let y equals f(x) be the solution to the differential equation dy over ds equals x plus y with the initial condition f of 1 equals 2. What is the approximation for f of 2? If Euler's method is used starting at s equals 1 with step sign h equals 0.5, right? Now we just get the table. Alright, initial condition is right here, s equals 1, y equals 2. So we just place 1 and 2 over here, right? Now the step sign h equals 0.5 and the final value of s should be 2, right? So you just keep adding 0.5 to s value until you get 2, right? So 1 right here, 1.5 right here, and 2 right here. We stop right here, right? Because we need to calculate f of 2, right? Now, dy over ds equals this formula right here, s plus y, right? So you just add 1, 2, it's going to be 3, right? Now, you need to find the equation of the tangent line, right? So we know that y minus y1 equals m times s minus s1, right? Or y equals m times s minus s1 plus y1, right? So I have y equals m equals 3 right here, right? This one is the slope times s minus s1, s1 is right here, and plus y1 is going to be right here, right? Now we substitute 1.5 for s into this equation to find the new y value right here, right? So we have 3 times 1.5 subtract 1 is going to be 0.5, right? Plus 2. So it's going to be 3.5, right? So right here I just put 3.5. Now the new slope is 1.5 plus 3.5 is going to be 5, right? Equation of the tangent line y equals 5 times s minus s1 is 1.5 plus y1 is going to be 3.5, right? Now substitute 2 for s over here. We have 5 times 2 minus 1.5 is going to be 0.5, right? Plus 3.5, right? So it could be 2.5 plus 3.5, it could be 6. We put 6 over here. The answer must be C. Now let's move on to question 2. Question 2 is similar to question 1, right? So I'm going to leave this one for you to practice. The answer is D. Now let's move on to question 3. Alright, question 3 is similar to question 1 and 2. We just get the table. The initial condition is right here, s equals 0, y equals 1, right? And look at the steps right here. 2 steps of equal sign starting from s equals 0 and then ending as negative 0.6, right? So this guy must be negative 0.3 and this guy should be negative 0.6, right? Now dy over ds, we're going to use the formula right here, right? S plus 2y, right? So it could be 2. Equation of the tangent lines y equals, the slope is going to be 2 times s minus s1 is going to be 0, right? plus y1, which is 1, right? Substitute negative 0.3 for s over here. So we have 2 times negative 0.3 is going to be negative 0.6 plus 1 is going to be 0.4, right? Put 0.4 over here, right? Now dy over ds is going to be s plus 2y, right? So it's going to be negative 0.3 plus 0.8, right? So it's going to be 0.5 right here, right? So y equals 0.5 times s minus negative 0.3, which means at 0.3, right? Plus 0.4. Substitute negative 0.6 right here. So we have negative 0.3 times 0.5 is going to be negative 0.15 plus 0.4 is going to be 0.25, right? So we put 0.25 over here. This one is the final answer. The answer must be D. Now let's move on to question 4. Assume that f and f prime have the values given in the table. Use Euler's method with 2 equal steps to approximate the value of f of 4.4, right? So 4.4 is the final values right here, right? Remember, we have f of s equals the slope times s minus s1 plus f of s1, right? F of 4.2 equals the slope is negative 0.5 right here, right? Times s minus s1, but s1 equals 4, right? Plus f of s1 actually 2 right here, right? So f of 4.2, substitute 4.2 per s over here, we have negative 0.5 times 0.2 plus 2, right? So it could be 1.9, right? Now f of 4.4 is going to be, the slope is right here, right? Negative 0.3 times s minus s1 right here, 4.2 plus the values right here, right? 1.9. So it could be negative 0.3 times, substitute 4.4 for s over here, we have 0.2 plus 1.9, right? So it's going to be 1.84. The answer must be C. Now let's move on to question 5. Question 5 similar to question 1, 2, 3, 4, right? So I'm going to leave this one for you to practice. The answer is C. Now let's move on to question 6. Consider the differential equation dy over dx equals ax squared plus 4 over y, where a is a constant. Let y equals fs be the particular solution to the differential equation with initial condition f of 0 equals 2. Euler's method starting from s equals 0 with step size of 2 is used to approximate f of 4. Steps from this approximation shown in the table above. What is the value of A? Now we have the equation of the tangent line is going to be f of s equals the slope times s minus s1 plus f of s1, right? Now we have f of s equals, we need to calculate f of 4, right? So we need to use the previous s and y values right here, right? So the slope is given by this formula, right? So we have a times s squared, s equals 2 right here, so it could be 4, right? Plus 4 divided by the y value, actually 6 right here, times s minus s1, which means 2, plus f of s1, which means 6, right? Now f of 4 actually 10 right here, right? And it's going to be substitute for s over here. We have 4a plus 4 divided by 6 times 2, right? plus 6, right? So it's gonna be 4a plus 4 divided by 3 plus 6 equals 10, right? It's gonna be 4a plus 4 plus 18 subtract 30 equals 0, right? So 4a equals 8, then a equals 2, right? The answer is B. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.